So last time we were looking at this problem where we're shipping goods from these cities to these locations, given these distances and these restrictions on demand for goods and supply of goods. And so we made an initial guess just randomly and generated these costs. And then this total cost right here. So now we want to use Excel to solve this question automatically. So we're going to use Excel Solver. So here is the solver. If you don't have Solver, then you need to go into Excel options and go to add-ins. All right, there's a add-ins over here, and then down at the bottom, and go, and then you have to select it from the box that comes up. So you would make sure Solver is checked. So we are going to use Solver, and Solver is going to say set target cell, and we want the target cell to be that total cost. So we want this cost to be minimized. So we're going to minimize the total cost of transiting all of the goods by changing, and now I'm going to hit guess just for fun. So B7 to E9, those are the ones we want, and then B2 to E4 we don't. There we go. So I'm going to change those 12 cells. Now if I just solve it right now, it's going to be really easy. It's going to put 0 in for everything, and that will be the solution. So we need to put the constraints in. So let's start adding constraints. So what's one constraint? One constraint is that the total cells in these three need to add up to be 9 or more. We need to meet the demand. Okay, so I am going to put that in right here. So we're going to say, right here's the actual constraint, and this will be how much we actually deliver. So sum of these three. So that's how many we actually deliver. I'm going to copy and paste. Control V, Control V, Control V. So now this is how many we are actually delivering given these choices of what to deliver, these choices. Now, we can also figure out how much of our supply we're using. So we need the sum of these. So sum of these. So we're using 8 of our 10 supply here, and we're using 13 or 15 supply here, and we're using 8 of our 8 supply there, given the setup. All right, so now that we've got these in, we can go to Solver and add those constraints. So we want this cell. This is a demand cell, right? We need to have at least 7 there. So we're going to say greater than or equal to 7. We want, or excuse me, 9. We're demanding 9 there. So we need to increase that. And I'm going to do that for all of these. So we're demanding 10 in Madison. So I'm going to say that is bigger. Oops, is bigger than 7. Add this cell has to be. I'm pushing tab to get here. Tab greater than 7. Add this cell. Tab greater than 3. Add. Okay. Now the supply constraints. We need New York, all of the New York, to total less than the supply in New York, which is 10. So we'll say this number, tab, is to be less than tab 10, add this has to be less than 15, and this has to be less than 8. Okay, so what we've set up now is we're going to minimize the transit costs, making sure that we don't ship more goods than we can produce, or deliver less goods than we need. And additionally, in Excel, in QM you don't have to, but in Excel we need to select all of these cells and make sure that they are greater than or equal to 0. There's no shipping negative goods anywhere. And then I'm going to hit OK and be done. So now we've got a bunch of constraints here. We've got, our 3 supply constraints, our 4 demand constraints, and our non-negativity constraint. And we're minimizing the total cost, the sum of all the sum of the units times the distance for all the different units and distances, by changing how many we ship. So I'm going to push the solve here, and it's thinking, and solver found a solution, so we hit OK. So notice we are shipping exactly the right amount to all. We're meeting demand in our warehouses, and with that, and no more. And that makes sense. Why would we ship things we don't actually need if we're trying to minimize shipping costs? Then notice that we use all of the production in San Diego, but we use something less than the maximum in Atlanta and New York. Okay, and see, we are so El Paso is being met by both Atlanta and San Diego. Anchorage is being met both by New York and San Diego. Madison is exclusively sourced by New York, and Topeka is being sourced by both Atlanta and San Diego. And that is a solution to the linear programming problem. So you have a minimum distance, 62,500, and a policy that gets us to that minimum distance. Okay, so next we will do the same thing in QM.